Hello everybody and welcome back. So we are going to get into how to mess with in RSLogix Micro Starter, the basic version of RSLogix500. We're going to show how to write a few programs. So this right here is the main program. So let's just say for this main program, let's just grab this. Ooh, that does not look visually pleasing. See how all of these up here are grayed out and only a few of these will actually show up? That means that this is the bare bones of what you can do with this RSLogix500. So right here is a jump to label, and we're going to do jump to subroutine. So for right now, I'm just going to add this to the rung. Oops. Let's go ahead and just put you in here. And so what I'm going to do for this is, for the main program, for most programming, anything from Java to C, which this is based in C and Java is based in C, or MATLAB or Python, whatever. You want the main routine to look very similar. And so if you have an error or anything, it goes, oh, this subroutine. So you're not having thousands and thousands and thousands of lines to go through. You only have 10, and then you go to something else that has a couple of hundred. Or that next subroutine might have like 2 or 3. It's much easier to parse it out and have a whole bunch of different programs, a whole bunch of different ladders in this case. So you have your program, and you have HSC, which is a high-speed counter, which is for encoders. Like an encoder is something that you put onto a conveyor belt so that you know exactly what position the product is on top of it. So let's say you have boxes going down a conveyor and you put an encoder on it, and the encoder updates every 1/10 of an inch. And so you know every 1/10 of an inch where that box will be. So you can do timers and stuff like that off of it, or you can just say, oh, in 5 inches, I want this box to take a picture, or a camera to take a picture on this box, and then 3 inches after that, I want to blow it off if it's bad, or something like that. So we're going to jump to file number, and let's say we're just going to jump to file number 6, and then jump to intro wrong. Let's just say it that way. So let's say okay. So I'm going to delete this out of here, and I'm going to delete this out of here. And so we have, every time it'll run this program, if there's no initial condition, which is on the left side of these rungs, that's what I did last episode with an input. I put an input here, and then I had an output. So I'm going to say, okay, we have this input right here, and if the input condition is met, I'm going to come back over here to the bit stuff. And so right here, if I can hover over it, it shows examine if closed. So I'm going to just go ahead and make this so that we can jump to this subroutine, and I'm going to compile this, and it's going to say, okay, so now we're going to come down here into 6. So right here, I'm going to click on the user, because these are the favorites now, or in Studio 5000, this rung is now called favorites. So we're just going to create a new rung. So we come up here, we grab it, and we drag it down, and it has this green little X here. You let it go, and there you have a new rung. This rung down here, all it does is end this, and then it just constantly loops through this, this ladder. And so you say, okay, I want an input, and I want an output. So let's say that the input, let's put it in a real life example. So let's say you're sitting there in front of your TV and you want to turn it on. So you push your power button on the remote, and it turns on the TV. So the input is you pushing a button, and the output is the signal being sent from your remote to your TV. And that's the example right here. You do something, or something happens. You can have an input be a switch, you can have it be a button, you can have it be a level sensor, you can have it be a photo eye, you can have it be something physical. There's a sensor of some kind. It could be temperature, it can be anything that you can physically sense, or it can be something through Ethernet if you have a more updated processor, something to turn on a bit somewhere. So if the condition here is if this condition is met, if a button is connected, which means that the electrical diagram of it is it just connects, like it just closes the circuit, and then it just goes around, the electricity goes around through everything, and it energizes the system. If you turn on a button, it will do an output. And so right here, let's just go ahead and we come down here to an input, and I'm going to grab this input 0, which if we remember over here, oops, right here, input is on the top side, and it is one of these right here. You just put a wire into there for your input, so that means a positive signal will be sent to that input, and then you have the negative output. Let's see if I can find a better picture here. Here we go. This is a really good picture. So let's say for the electrical diagram, this is what I was showing last time of here's your L1, here's your neutral, and here's your ground. And so that right there, this one would go off to a wall, I think. This might be a 120 volt version. But anyways, let's say you go to output 0, which can do voltage AC, which can be from a wall, or voltage DC, and they're rated to a certain amount. Or down here, all of these actually are. So this is a really good processor actually. So these are the outputs, and then these are the inputs. So AC common, okay, so this is an AC unit. So let's pretend this is going to actually be a light switch or something. So you would have your negative coming through here, which is your neutral wire. So you'd have your neutral wire coming through here, or your negative, depending on if it's, in this case it's AC, so it's a neutral wire. But if it was DC, it would just be a negative, because DC goes in a certain direction. And then you have this right here going to your positive. So it's easier to understand in a DC nature. So I'm going to keep describing things in a DC nature. So you have your negative come into here, and your positive connected to here. So let's say you have a battery out here, and it comes in and it's sending a positive signal here, and then you have this going to the negative side of the battery. And then whenever you want, you can programmatically in starter, you can say, okay, I want this to be switched on. So with that, you want to switch as well in this circuit. So you have your positive going to the positive of the switch, the negative of the switch going to the positive of this, and then the negative of this going to the negative of the battery. So if you can picture that. And then let's say that you flip the switch, and this goes, oh, I'm on all of a sudden, which it now goes, okay, this has been closed, the circuit has been closed, which means everything's continuous, electricity can flow. And so now, let's say this is your switch. Let's just say it's a very simple switch. So there you have your switch, and then you want to come over here to output, or you can just click on the arrows down here, and you go to an output, and you say, if that switch is coming on, you grab it, highlight it, and you drag it over, and there you have that. And I need to get back into outputs. So then you come down here to description, and you say, I want to turn on a light bulb. So you turn on a light. And so the output of this, to set this up electrically, this programming is, I would say, 80% electrical and about 20% programming for this simple of a module. It takes far more time to get it set up and figure out how you're going to do everything than it does actually just doing it, unless you're dealing with something that's very fast or top edge, and you have like a Cognex camera or a Basler camera or some banner sensors or Keyent sensors or something like that, like something way out of the way of this. And you have something that's like a very smart system. For very basic things like turning on a light switch with 2 inputs and then turning on a light switch with the 2 outputs, or 1 output and 1 input, is very simple. So for this, let's say you have a LED, and it actually, you have a series of resistors or something that makes it so it doesn't pop or anything like that. And you have a simple LED, and you come in through here, and you have your positive coming out of the system and your negative going in here for your DC. So let's say you have a positive, you have your battery down here, and you have your positive coming up through here, and then you go out through here to your LED, and then you connect the other wire down to the battery. So in the program, when this switch is turned on, let's go ahead and compile this so it doesn't have that error on the side. So whenever you push your switch, let's go ahead, and I'm just going to go ahead and I'm going to force this on. So this is on. That means that this would turn on. So we're not live right now, so I'm just going to remove that for us. But if we were live, there would be a green outline right here. And then this would turn on as well. So that means if we had the switch on, we would turn on the light. And so this is the very basics of how to do an initial input and an output. So now we're going to go into, let's say I want this to be on a timer. So let's say I push the button and I want it to be on a timer for, oh, I don't know how many seconds. I'm going to make this full screen. So window, arrange, default. Okay, so there we go. So I want this to be on a timer. I'm going to bring the timer over here because if I click on that, I can still kind of click it. So I want this timer. So we have a timer and we want it to be a timer on delay, which means that I'm going to go ahead and put this timer in here, T40, which is the basic timer. There's a whole bunch in here, but we're just going to use the first one for right now. So the time base of this is 1 second, which it can go down to a millisecond for some processors, but a couple of them won't let, like these micro 1000s, they won't go below 1 second. They might go to a hundredths of a second, but I'm not sure about that. I haven't seen one that has. So let's say you turn on the light switch and you have a timer, and let's say you want it to act for 2 seconds. So you want it to be on for 2 seconds. And so you have an output of whenever you turn this on, it turns this on for 2 seconds. So you come here and you go, all right, so whenever this is actually counting and enabled, you want to enable that light for only 2 seconds. This TT bit here, that means that it is all both enable and done until it's reset. And then done means this will turn on for 2 seconds for the timer, and then whenever it is done timing, you can use this done bit. And so let's say it's more of a pause of you push the button, and let's say we put this done bit in here. Then that means you push the button, it counts for 2 seconds, nothing is happening to the light for 2 seconds, and then it turns on until this is now reset. But for right now, let's just have it so it's whenever it's on. So we have that whenever it is on. And so we have the timer count for 2 seconds, it turns on the light, and whenever it is now done with that timer, we want it to reset this timer. All right, so let's go through this again. I'm going to go ahead and compile this to show it works. So you push your switch and it goes to a timer. While the switch is being pushed for 2 seconds, you have to constantly be pushing it for 2 seconds. It will enable a light for 2 seconds, and whenever it is done, let's say you let off the button, it was exactly 2 seconds you were holding the button down. It comes over here and it resets after those 2 seconds. So let's say you have a momentary for this as well. So we're going to come in here and we're going to make another rung, and I'm going to move this down as well. And let's say you have a latch and you want this to be going to really nothing. So I'm going to put this in a binary, which is an internal bit. These are all internal memory. They are not outputs or inputs. They are just here for internal memory. So let's say I put that there, and I'm going to describe this as a latch on for switch 1. So it's a latch on for switch 1. All right. So while this latch is on, I'm going to make it an input here, and you can grab this and you just put it right here. So this will turn this on. This input will say when this output or when this bit has been turned on, we are going to turn on a timer. So whenever we turn on the timer, we enable the light for 2 seconds. Whenever it is done, we reset. So this can be the smallest of time. Let's say that the scan rate of this whole program is 10 milliseconds. Let's say you have it on for 11 milliseconds. And then it turns on this bit. Then it turns on this timer. And we go through the whole cascade. And then whenever this is done, whenever you want to reset this, let's say you also want it to, at the same time, you want it to unlatch. So let's bring it unlatch, which means you want to turn this bit off. Okay, so let's go through this again. It's going to kind of get repetitive, but it takes a little bit of doing to get your mind molded into this. So we have a switch. We push the switch for 11 milliseconds, or any time. Let's say that no matter how fast you press it, the processor is fast enough to catch it. So let's say you hit this switch, it latches it on, which means it is a latched. It's kind of like a light switch. You hit it up and it stays there. It doesn't automatically flick back. It's not like your remote button. You flick it up and it just stays there. And so while it's in that position, or that while the bit is activated or there's power going through, logically going through, you turn on a timer for 2 seconds at a time base of 2 seconds. And while that timer is going, you have a light come on for those 2 seconds. And the second it is done with the timer, you reset the timer and you unlatch that bit, ready for the next switch. So I hope this has helped you just to get a couple of basics down for how to do this programming. So if you have any questions or any comments or anything, please let me know and I'll try to address those into the next video. So I really appreciate if you've watched this, and have a good day. Bye.